Welcome back everyone, and in today's video we're going to complete the planet thing I've been wanting to do for the last couple videos. We're kind of been building this planet, learning bump mappings and everything else. So here's the final product. This is what's we're gonna end with at the end of this video. So we're gonna have a planet, and as you can see there's like these lines, and then there's like projectile that's kind of flying around, and every time the projectile lands creates a nice black spot. So basically it's a rocket coming off the planet, going into orbit, whatever, and then coming right back down and destroying part of the planet. And if you just leave it running for a while, eventually the entire planet will be black because, you know, it suffered nuclear Armageddon or something. There's extra things added to the planet since last time. There's the atmosphere. I'll show you how to quickly add the atmosphere. And yeah. So this is going to be the final product. And on top of that, I threw a sky map in there just to make it look nicer. And I got the sky map from NASA. NASA, I'll put the link in the description, has a bunch of images you can get, like textures and stuff that you can use for stuff you want. Yeah, they have a bunch of cool things. I tried some of these grids out to overlay. I didn't like it. I'm not using probably the best shape for it because it's kind of blurry. I'm not sure if, I don't know what texture is wrong with here. I don't know if it's just not a very spherical texture, but whatever, good enough just to get this idea over with. So yeah, planets being blown up little by little. So I don't want to go too deep into the code because it's a lot of things we've done in the past. So I'm just going to go through some of it, not all the code, because all the visualization stuff we've done before, like how to create lines, bezier curves, and everything else. We've done videos about that. So to create that effect, I created like 2 prototypes first. So here's the first prototype of basically all it is just a bezier curve, and it uses 6 points. 1, 2, that's 4, not 7 points. There's 7 points, and there's only 3 knots in our bezier curve. So it's basically 2 bezier curves attached to each other. So from green to blue and blue to red are 2 bezier curves together, and when you merge more than 1 bezier curve together, you make a bezier spline. So, and in the bezier curve, you have control points. So at the top, there's the actual point, and then there's another control point that controls how to curve it. And here there's another control point. So you can kind of see that the greens are this side of the bezier curve, and the red points show you the other bezier curve in the spline, where the blue is the center. To make a nice smooth kind of like curve, all you have to do is take the first and last point of the curve, determine its slope, or basically, and since it's 3D, basically it's like direction, like its normal direction, and then I can just take that point and just add and subtract that normal direction and apply those values to the bezier curve. So this way, the control points are parallel to the beginning and the final. So it makes things a lot easier when I want to change things. Let's see. So this one allows me to change the position. So there's the beginning, that's the end, and again, you can imagine the curve, the slope, and this follows in parallel to it. So it's very simple, and the other control points use the normal direction of the point itself. So it's points at the actual point, actual normal direction. So wherever it is on the sphere, it takes that normal direction on the sphere. And so yeah, and it's fairly smart enough to just curve itself where it makes sense. It doesn't really take too much work to get it curved right. Let's see if I refresh and try to bring this up. The only problem is when you come up here, the curve isn't as good. I probably try to spend more time on trying to make the control points a little bit smarter, but For this quick demo, it's good enough. Like I said, I just wanted something fairly quick just to finish off the series a little bit. But yeah, and then I have like this little control point that kind of just moves the points based on longitude and latitude. And there's math equations that allows you to convert. I think those are polar coordinates. I may be correct. Polar coordinates to I can't say it. To basically XYZ positions. Cartesio. I can't say that word. Can't say it for the life of me. So this is the first prototype, but just how to create the line, curve it correctly, and then have like a little dot that goes over. And we've done this before in the Bezier curve or Bezier spline editor that we did in 3D, like probably like a year ago. So it's really just using all that information, all that knowledge, and just doing this. It's pretty easy. Let's see. We can look at source code. So it's this prototype. It's very simple. Like I said, here's the spline. I know where the knots are. So that's the first point. That's green. This one will be blue, and that one's red. That's the control point that connects to that. That's the control point connects to that. And since this is the center, these two are the center point, the green and red. So that's the spline. It's just points on, an array points of, essentially. That's all it is. And when I created the curvature, like depending on how far apart, it was kind of really just a trial and error. When the dot notation between the 2 points is a 1, I played around with 2 different values, and then I tried different scales, like get it closer and closer, and then see what made the curve look good. And then using the dot notation as a scaling value between 0 and 1, I just kind of go from between here and 1, and it works fairly well. That's why I said that depending on certain angles, the curve isn't as smooth as I would want it, but I kind of cheated. I kind of just quickly see what works, good enough. Let me just scale. Let me just lerp it. So basically, I do use a lerp. There's the overlay stuff. There's really not really much to it. We have the rocket, which is just a point. We have another point object, which just holds all the points that we can see visually of where the knots are in the Bezier spline, the line that we're drawing, and then the sphere. And we just animate it. I added new functions, polar to Cartesian. And now that I can see the word, I can probably say it better. And like I said, all it does is just take the longitude, latitude, and the radius and saves out that value right back into a vec3. So that's very quickly easy. If I go to Fungi, maths, in case you really care. Polar to Cartesian, and Cartesian to polar. I found that equation here. I actually tried a few of them online, and some of them just didn't work very well. So this one was like the best one. I don't know if he has a name. He deserves the credit. Germs, yeah, him. But yeah, his sample worked out really well. So yeah, I probably just changed it a little bit here and there, but overall it's the exact same code that he wrote. So it works beautifully. It works back and forth really beautifully. So yeah, we take that value, what position, and we kind of just do random. Or actually, no, not this one. In the final version, we just do random points. Here we're defining it by using our overlay controller. So yeah, we just normalize the beginning and the end points. Then we use the dot notation, and that gives us our dot, and we can use that as a scaling value. I rescale this from -1 to 1 to 0 to 1, so I can use that, like I said, as a lerping value, And then to get the midpoint, I just lerp between the first and between the first and the final point. I say I want the halfway point, and I save it. So I'm just lerping it, and then I just normalize it, scale it. I don't know why I'm scaling it. Oh, once I have the actual point in the middle between the lines, then I got to move it. I got to move it out. So yeah, if I lerp that point to that point, it'll be right down here, and then I move it. That's what that line of code is doing. I'm scaling it. I'm actually kind of just adding the radius to it. These are just creating the control points, and like I said, it just figures out the parallel, and then just updates the 2 points. This kind of just visualizes pretty much everything. I think it also adds the endpoints. Scale. Yeah. There's also the control points for endpoints. Then I finally visualize all the points. And then I just draw all the lines based on the bezier spline at. Like I said, this is the same kind of functionality from the bezier video that I made probably like a year ago. I just went back and just kind of put it together in a neat way, in a nice cleaner way. Because I have 3D, but sometimes I think I have a 2D version as well, but it's not part of this project. So yeah, this whole class would probably be really great if you want to do bezier curves. In 3D, you get your get point. Your derivative is what you can use to step through. That's how the orange dot. You just feed in the spline value. Like you can put the spline value through here and just say at what point during the spline you want to be at, and it kind of uses the derivative to do it. So you just use derivative by just calculating it. Derivative is very simple. I don't remember where I found the equation. I think it's in the 2D version. It has a link. I think it was a Wikipedia page that has all the equations. So I just end up just writing them into JavaScript. So it was if I remember correctly, it was a Wikipedia page. Did I save that link here? No, I did not. Like I said, it's kind of it's from a year ago, so I kind of lost track of where I found some of this stuff. So that's the gist of just getting a rocket off and curving it around the planet and the crash landing. Now, the next thing I prototype would be the spots. So, and this is actually and it just does a random point and then just starts creating these spots on an invisible sphere. What is it? Actually, it is a sphere. You just can't see it because it's transparent. Can I actually changed the alpha value. That's where how it all becomes whatchamacallit. But that one is actually, like I said, it's pretty simple. I've done it before on the shield, where I'm making the shield effect and I want to do a hit. And I think I've done it other times before. And the idea behind it is that when you're rendering a pixel or a fragment of whatever shape you are, you can get the normal direction of it, right? And in a sphere, it's really easy to get the normal direction. So it makes like this probably doesn't work really well on a cube, but the way I do it works really great on a sphere. So every fragment is the normal direction back to the center. So never mind. Every point, if you normalize it, is back to it, but it works better on the sphere. But so the idea is that I take the direction of the fragment and then take the direction of the random point that I'm putting in there, and I'm doing a dot product. And by using that dot product, again, I use that value to just make a sphere. So if it's between angles 1 and between angles 0.9, it creates a certain size circle. As you can kind of see in here. Like I said, I've done this in the past before. The only thing I'm doing here that I haven't done before is the array. So in the shader, we have the spots, and I have an array of vec3s I have it set for 200. So once it hits 200, I don't know if it crashes or it just stops feeding in information into the shader. Or I might get like a shader error saying, okay, buffer overflow or something like that. So I pass in just an array of vec3s, and I have to send in the count, how many spots are there. Because just because there's an array, that doesn't mean they're all filled with data. They may be actually filled with garbage data. So I don't want to render things that aren't there. So I have to pass in the array, and I have to pass in like the array length into the shader. And it's very simple to do. We've done that before. It's all part of our update uniform function that we built like over a year ago. I've been doing this for like, I think, going on like a year and a half now with this series. But yeah, so I just keep an array, a flat array, and then I just pick a random point, save that random point after I normalize it to the array, put it into my material. So this way the material actually loads it into the shader. And then I'd save the count divided by 3 because that array is a flat array. So if I want to get a vertice count, I need to divide by 3. And that is really the simple gist of how to do it, like to get those spots. And I don't know if I already got 200 spots. No, the spots are still appearing. And you can see that more sphere. And this was the second prototype to actually complete it. So let's see, what a test. So this is what we started off from the last video. We have a nice planet. The lighting's done pretty well. When you get to the dark side, the texture changes to the nighttime. Over here you got the daytime. You got height maps doing bumping, normal bumping over there. Doesn't work very well when the light is dead on, but works really well on the side. So yeah, so we go back to here. Now, I did some changes to Fungi to actually make this thing a lot easier. And one thing I did to Fungi is that the scene object has now just more than an array. Because originally I would just feed in all the items to the scene into the array, and I would just render that. Now I have a new function which I can use as an option. This says prepare items. So it goes through the list of items and then breaks them out into 2 separate lists. Lists of items that are renderable and list of items that have an update function. So yeah. And the other thing it does, it breaks apart parent-child relationships. So parent-child relationship, the parents and children all exist within the render items or the update items list. So this way, I don't have to do hierarchy rendering because, like I said, the entire hierarchy is broken out into a flat array, which is quicker and easier to render a flat array than to constantly deal with parent-child relationships. So this would actually make performance a little bit better when you're dealing with rendering. But the beauty part is that like I said, I have 2 lists. That means I can put things in the scene that are not renderables and not cause an error. If I don't do the prepare items and try to render a non-renderable, the system will kind of break apart a little bit. I think I put some code in there just so it doesn't do it anymore. But yeah. And the best part is that update. So if you ever do like Unity, I don't have too much experience with Unreal, that every object has an update function. And that's where you kind of really throw most of your code. So I did that. So in the system, so every time the system does an update, which actually creates the next frame, I have something in here now that checks to see is there a scene update list. If the scene update list does exist, go through the entire list and call its update function. So this way we can now, instead of writing all our code in our unrender function event, we can break our code out in little tiny functions that exist within the objects to just make things, I guess, cleaner in certain ways. And then if a render list does not exist, it just renders it how it always has for the last since the new version. Else it uses the render list. So system and scene has been updated, so this way it's a lot smoother. The reason why I did that is because I want to put in a couple of things. So we have a planet, right? It rotates. So I need to put in a couple of things. First, I need to put in the bezier curve, and I need to put the rocket that's flying around. I also need to put in this sphere that has the dots. So, oops. So I need those things as well, and I want them all to be with the planet. With the planet was also sphere, so I need them all together. So first I thought I'm going to put everything under the planet, and that doesn't work very well. So because I want to do rotations, because I want to put the atmosphere too, and the atmosphere is the exact same thing as the spots. It's just another sphere that lives on top of it, and I want the sphere I want to rotate things at different rates, and it's easier if they were not if I didn't parent the planet along with I didn't parent the clouds with the planet. So what I did is that I actually created like a container, and the container is our transform. And if you remember when we're developing fungi, transform is the root object for our renderable. Our renderable extends transform. So, and transform also has our parent-child hierarchy as well. So that's really the root of our rendering system for the most part. So I use that as a container. So that's why I have to split things apart, because this is not a renderable, but it is a parent-child relationship thing, and it's something that can change things, because instead of rotating the planet and then rotating the spot, the clouds, the lines, the points all individually, I throw everything under the container, and I just rotate the container because it's the parent, and then the child will take that rotation matrix, or that world matrix, and then multiply it to their world local matrix to create a new world matrix. We've done parent-child relationship videos before, but like I said, now I'm actually really starting to use it in a more smarter way, because I built the system. I fixed up the system to handle it better. So our transform becomes our container, and then we add the planet to our container. And then, as you can see, our container I added an update function to it. And all it does a rotation. So our container rotates, and then just because the Earth is the child, it rotates the Earth along with it. So now the next thing I can do is that, like, I want to add the lines and the points. And what else? Add that. And that. So our logic is the same function from here. I guess it's reset points, but the rocket logic is it's all the exact same code, but just small little changes, and it comes with an update function. And the update function, it just handles the animation part of it. So I think. So yeah, I put the animation here on render. So, but here, like I said, I made its own update function. So this way, I can actually throw this object right into the update items list in the scene, and then when I start rendering during system update, it actually does the update for me. So, like I said, that makes it easier, so I don't have to put everything in the unrender function anymore. So I can just like make an update function. So this is how animation is being done. When the rocket hits the point, I think that's when it adds that spot to the array, and then updates the array and resets the points, and we start the whole process all over again. Yep, and at this point I make a random angle for each starting point and end point. So does it do the reset here? Yeah, it resets. So it resets everything. So all this is handled in the rocket logic. And ideally, just by doing that, there you go. And I probably should get an error because spots are not active. Oh. Well, the spots are probably there. I just don't have it. So let's just add spots. So spots, I just clone the Earth because it's a sphere. So I'm just reusing the VAO without recreating the VAO, have a different scale. And to make it not clip, I have to make it a little bit bigger, just slightly bigger. So this way you can see the sphere layer on top of the earth layer. Click save, and now I should be able to see the spots when it hits. Boom, there we go, beautiful. And the clouds are, like I said, are the exact same thing. So it's just another sphere, and it's material clouds. And the material clouds is very, very basic. It's just a texture. I just duplicated the planet shader from the previous video and just changed it so this way it only has one texture instead of like 3. So yeah, it's only one texture that we need, because the planet shader, I think, requires 3. Yeah, it requires 3. It has the color, the bump texture, and the night texture. So I just wanted to create another shader that uses less things. So it's the exact same thing, has the same lighting. So this way they kind of all match up. And refresh. And there you go. And you see that the clouds move along with it. And like I said, and it kind of creates that nice atmosphere look right there. Since it's has that it's layered, it's a little bit scale even higher, because I have to scale it higher than the spots thing. If I get rid of the spots, I can put 2.1 and it'd be a little closer, and I can put its own update function into it, right? And like I said, I wanted things to scale at different rates, so now you kind of get like a parallax effect going. So the planet's rotating and the clouds are rotating a little bit faster than the actual planet. So it's kind of hard to tell, but you can change the rate as much as you want. Now you can kind of see the clouds now really rotating much faster than the planet. And yeah, and that's it. We got pretty much most of it there. For a system, all I have to do is get rid of the grid. So no more grid. Remind me later. And all I got to do is add a Skybox to it. And I didn't actually do a Skybox. I didn't feel like rewriting. We did Skybox before, much early on in the series, and I used the cube. So you had to do like 3D textures, and I just didn't really feel like rewriting that yet. So I kind of cheated and just found this. That's why I went to NASA. I found like kind of the spherical texture, and I just threw a sphere on, and like I said, I kind of just reused the cloud shader, but I actually took out all the lighting. Star map. So it does a texture and no lighting. So it's just purely a texture shader. That's all it is. That's all it does. And I say call faces to no, because I want to see the inside of the sphere, because the sphere is now huge. Let's see, where is it? Skymap. It's like scaled at 100. I try to scale it to see if it improves. Maybe if I do 50, maybe that will improve it. I don't know. It's still kind of blurry to me. I don't know. But yeah, there you go. And like I said, this sky map, it all is just a giant sphere. Like we're inside the sphere. And there is the universe. There is our universe. So if we kind of fly right back in, and there we are. You know what, actually looks better this way. That's probably why it blurs in the corners, but I think the closer we get, the worse it feels. I guess we're getting too close to the but it's all right. So there you go. And that is it. That's really all to it. There's like a lot of little tidbits in here that you can like. It's really, this is kind of a combination of everything that we've done in a year and a half of developing fungi and studying all the little nitty gritties of everything. So now we can really start building these nice effects. But yeah, but the real magic is the textures. Like the textures are really well, and just a little bit, some lighting, and you're good to go. And yeah, the only difference is the cloud texture. I probably shouldn't mention this. If I go to README file, the textures come from here, but there's one slight thing. The clouds come in as two textures on the site. It's a cloud map and a cloud transparency. I didn't want to load two textures in, so I went into Photoshop. I put these two textures in and essentially used this as a layer mask to make the cloud map transparent. And I saved it right back out as a transparent PNG. So if you really don't want to do that, and if you really don't want to have to deal with doing it yourself, or putting these two textures in, and then you have the shader add the alpha transparency to it, it's in the GitHub with everything else. Where is it? Earth. So yeah, there it is. So that's the only big difference really, is that I just modified that image file, and so this way I only have one texture, because I don't feel like loading two textures in when I don't need to. So yeah, that's the only other little tidbit. And like I said, NASA gave us a pretty cool. If you go around, they have more textures that you can probably use. Like I said, I tried some of these grids; they don't work out. I'd probably just need a better shape. Like I don't know what sphere shape this is, because it doesn't look like the sphere that I have. So this, I don't know what shape this is using. That's why probably the textures don't line up very well for me. But like I said, it's good enough. And I should just leave and just close this out. Refresh. This way, nice full screen. And here it is, planet Earth, slowly being destroyed. That's the end of our video. I got you everything. All this will be on is on GitHub. It's been there for a while. Lately, I've been just posting my lesson video to files up on GitHub before I even make the videos, because I'm actually about 3 videos behind at the moment. I have 2 more videos to do, so I'm a few lessons behind making videos. So if you want to skip ahead and kind of see what's coming up soon, you can go to GitHub and see lesson 90 and lesson 91. Just the source code, basically. You'll love 91 because it is a terrain level editor. Very basic, simple one. I think you guys get a kick out how to build a simple one as a starting point for any major projects you want to do or applications you want to try out. So that's 91, but we got to do 90 first, which is normal mapping, which is very important because we did bump mapping and now we need to do normal bump mapping. And yeah, I don't know why that little glitch is, but whatever. So yeah, I guess I'll end the video now and see you guys at the next video.